For number 6, we have a shipment of 10 televisions. 2 of them are defective, which means by default 8 are working correctly. We're going to randomly select 2 of them and first find the probability that both televisions work. So we're going to multiply the probability that the first one is working by the probability that the second one is working. And on your first choice, you have 8 working out of 10, so you have an 8 out of 10 chance of getting a working television. And multiply that by your second choice. Now there's just 9 total televisions left. You've already chosen a working one, so there's only 7 working televisions left. So you have a 7 out of 9 chance of getting a working one. So the probability of getting a working one on your first choice times the probability of getting a working one on your second choice gives you the probability that they are both working. And that reduces to 0.622. And for the next part, we can use the complement rule to find the probability that at least one of the 2 televisions does not work. Because here we figured out the probability that they both work. So if they're both working this percent of the time, then all the rest of the time, either one's not working or they're both not working. But 0.378, you will have at least one defective not working, and the rest of the time we'll have them both working. For number 7, you've bought a CD with 8 tracks on it, but unfortunately you only like 2 of the songs. So if we play this CD on random, it's going to pick each song one time in a random order. Find the probability that out of the first 2 songs played, you like both of them. So you multiply the probability that you like the first song, which you have a 2 out of 8 chance, multiply by the probability you like the second song. Now there's just 1 song you like left out of the 7 remaining tracks. So multiply that, you get 2 out of 56, which reduces to this. That's pretty unusual. That's about a 3% chance, 3.6%. So it would be very unusual that you like both of the songs out of the first 2 played. The probability that you like neither song, that means the first one's bad, which means it has a 6 out of 8 probability. And the second one's also a song you don't like, so it has a 5 out of 7 chance. Multiply that out and you'll get this probability. The probability that you like exactly one song. So listening to the CD, you could like the first one. It has a 2 out of 8 chance. And then that means exactly one would mean you don't like the second one. So it's one of the 6 bad songs out of the 7 remaining. And that has a probability right here. But it could also happen that you dislike the first song, which has a 6 out of 8 chance of happening. And then you like the second one, so one of the 2 good songs out of the 7 remaining. And that has the same probability of happening. And so either one of these situations would result in exactly one song you like being played. So add those 2 situations together and you get the probability that exactly one song you like is played in the first 2. For part D, we're going to redo A, B, and C, but now when we put our CD player on random, it's possible for the same song to get replayed before another song even gets played at all. So what's the probability that you like both songs? Well, the first song, you have a 2 out of 8 chance of liking it. And again, since everything has a chance of being replayed, the second song, you still have a 2 out of 8 chance of liking it. So that comes out here. What's the chances you don't like either one of them? The first song, you have a 6 out of 8 chance. And again, the same probability on the second song because a song can be repeated. So you come out to that. And then what's the chances you like exactly one? Well, you could like the first one and dislike the second, which comes out to this chances. But it's also possible to like or dislike the first, but like the second, which comes out to the same probability. So either one of those cases would be exactly liking exactly one song. So add the chances of both of those together and you get this for the probability that you like exactly one song. For number 8, we have a bunch of bulbs in the bag. There's 29 total. The probability that both are red if you select 2 of them. So multiply the probability that the first one's red. There's 13 red out of the total 29. And then since you've already selected one remaining in the bag, there are 12 out of the 28 that are still red. You'll get this, and here's the probability. What's the chances that the first is red and the second is yellow? The first one being red, there's 13 out of 29. And there's 8 yellow bulbs and only 28 left in the bag, so that's the chances that the second one is yellow, and you get 0.128. The chances that the first is yellow and the second is red, it's a little flip-flop here. There's 8 yellow bulbs, and there's still 29 in the bag. And then on your second draw, there's 13 red, but there's only 28 in the bag. You'll get the same probability. The probability that one bulb is red and the other is yellow, so it's either this situation or this, that one of these things occur. So just add together the probability of both of those, and you get 0.256. For number 9, we're given the probability of randomly selecting a jogger, and then also we're told the conditional probability that if we randomly select a jogger, the chances that they are a male. And we're asked to find the probability that the randomly selected person is both, that they are a male and they jog. And there's a couple ways you could think about setting it up. You can use this formula for conditional probability. The probability that they're a male, if we know that they jog, if we're given that condition. You put the probability that they're both on top, and the probability of the condition on bottom. And we're told 2 out of those 3 things, so to solve for this probability that they're male and jog, you would multiply both sides by 0.202. So you get 0.223 times 0.202, and there's your answer, 0.045. And another way to think about setting it up, anytime you're solving for an and probability, so the probability of male and jogging, you just multiply the probability of each item together, but you have to use conditional probability for one of the 2 items. And unless they say the events are independent, and then you could just not use conditional probability. But we're not told these are independent, so we're going to use just the probability that they jog, which we're given in the problem, and then use conditional probability for the other piece, which we're also given, the probability that they're male, given that they jog, and multiply those 2 things together. You're basically doing the same math you did up here. It's just looking at it from a different perspective.